Are you okay sharing this with the rest of the class?
Yes.
All right. You can share your screen or however you want to do it.
Okay. Um, my first question, I have a feeling that these will probably be always, sometimes never, so I just wanted to go through them. Question
Okay.
7 on,
Are they true, false?
well, some of them, yes, this is a true false. So that's and there's a bunch of them on this homework. So I'm
There
like, oh
is. I know it's
God,
wonderful. I know.
no.
All right. Well, you want me to open up the book to the
Yes,
page, or what do you
please.
want to do? Okay, give me a second. Let me do that. Let me find where I'm logged in. Okay, and what 7.5 you said?
Yes.
And is it the homework part or the
The homework.
okay? Let's see here. I think okay, math connection 7.5. All right. Here we go. So I'm going to pull this one out, and now we're ready to go. Sharing screen with this 3, 2. You should see it. I hope. I hope.
Yes.
Okay, go for it.
Okay. It says the sum of any two rational numbers is a rational number.
Mm-hmm.
And I want to say yes, that's true.
Yep.
There's no like
Why?
time. Why is that true?
Yeah, because if it's always sometimes never, it's not just true.
Well, if it can be in the form of A over B,
That's a rational number. Yep.
AB plus AB,
Oh,
that
careful.
equals,
Make sure I understand what you're saying. So it's
okay.
two rational numbers though, right? So we have
Yes.
something that looks more like I'm assuming you're on 7A is the one you're talking about, right?
Yes, 7A.
Okay. So if you have so you have two rational numbers, we don't know what they are.
Yeah.
Okay. Question is the result from this, because it says sum of two rational numbers, is the result of this a rational number?
I want to say yes, just because this is what we did all of last, like the few sections.
So what's it going to look like then?
It's gonna look like AD plus CB over BD.
AD plus BC, the whole thing over BD, because you got a common denominator, floffing, and there it is. Now remember, rational number has to be in the form of something over something, as long as this one is not 0. So you definitely have that form, right?
Yeah.
Question is this thing 0?
I mean, I don't know. So what if it is?
Well, we know you picked a rational number, so I know B is not 0, and we know you picked a rational number, so D is not 0.
So then it works.
So then it's definitely not 0, and therefore this is a rational number.
Okay. Okay.
Yep.
Um, so then is it okay if I go through all of them with you? Just to like,
So because you're just talking them out, I'm going to ask you questions too, so it's not just about me. So
yes, no,
you
I
ready?
know.
Okay.
This
Okay.
helps me. This helps
All
me.
right. All right. Go for it.
Okay, the difference of any two irrational numbers is an
Hmm.
irrational number.
Okay.
So like I'm thinking of like the square root of 2
Hmm.
minus pi.
Minus pi. Okay. That is irrational.
Okay, so is there a time that this is a
Well,
rational?
you just picked two of them, right?
Yeah, so that doesn't prove it.
Yeah. That makes me wonder though, right? You did the square root of 2 minus pi,
Yeah,
right? And it says any.
yeah.
Any.
Any
Hmm.
any irrational number.
Yeah.
So 0.
0 is a rational number because I can write it.
Okay, 2. So is
This
there, well, what if I do, what if it's, can they be two of the same?
just says any. So
Yeah, because if you do the square root of 2 minus the square root of 2, you're gonna get 0, and that's not irrational.
um, So if this was always, sometimes, never, you would say,
sometimes. Okay.
then you'd have a reason for it. Another one you could do that is not exactly the same number. This one almost feels like cheating a little bit, right?
Yeah.
'Cause you're like, same number, that's kind of cheating. Not really, but you could have said, what about 3.121121112111112 dot dot dot
Mhm.
minus 2.1211211121112 dot dot dot.
Yeah.
They're both irrational. When I subtract them,
Yeah.
I get
Okay.
one. So
Yeah. So that's sometimes. Well, it's false for the homework, but sometimes if this were to be on the
it
test.
would be false because you could give a counterexample.
Yeah.
But remember, true and false in the book is true means always true.
Yeah.
False means not always true. It does not mean that it's always false. So just make sure that's why I don't like those questions, because I don't think even a true false question is not being clear on what it's doing. So
Yeah.
okay.
Okay. And then the product, which does multiply.
Yeah.
Any rational number and any irrational number is an irrational number.
Mm-hmm.
I want to say that's true.
Okay. Give me an example.
Like one, because I can do one, right? Or no,
Sure. That's a
that's
rational number.
okay. One times. I'd always just think of square root of 2 because that's like
I already started writing it. I was like, she's going to say square root of 2 because she's just in love with it over here. So 1 times the square root of 2, that is a rational number and an
Mhm.
irrational number. And that is equal to,
Wait, no, because if the rational number is 0, then it's 0 and that's rational.
See, remember what I prompted in class. I said, when you're seeing these, be thinking of, like, for integers, think of negative numbers, think of positive numbers, and also think of 0 as a different case. So you pick any rational number you want, multiply by any irrational number you want, and it doesn't always happen.
Always work. So that would be false, but sometimes.
It's false, but sometimes.
Okay. Okay. That makes sense. And then what was my other?
Oh, what if I change this? Because you're a big what if person in class. At least when I'm up in front of everybody, you have no problem with the what ifs. What if I do this?
A sum of
Mm-hmm.
a rational and an irrational.
Mm-hmm.
So if it's 0, which is rational, plus a irrational, it's going to be the irrational.
Okay.
It's going to be irrational.
You sure?
Do
you think always?
Yeah, I do.
Okay. So you're thinking always. Now you know you got to justify it. How come?
Because, well, if it's rational, it can be a over b.
Mm-hmm.
And in an irrational can't be a over b. So I don't really know. But that's just like I don't know how to prove it.
So there's a couple ways you could do it. There's a couple ways you could do it. So you could say, well, I wonder if I start with a rational number plus an irrational number, and let's just pretend that I end up with a rational number, right? Could that happen? Well, if that does happen, then you could say that your irrational number would be equal to C over D minus A over B, wouldn't it? Let's bring it to the other side, because that's a definition of subtraction, is the addition piece. And we already know this, because subtraction is the same as adding the opposite. Therefore, it's the same as the addition one that you had up here. And you said the sum of any two rational numbers is a rational number.
Yeah.
So this would be BC minus AD, all of it over BD. This is a rational number, but what is this thing?
Irrational.
So we've got a pretty serious problem. And this is known as, again, that contradiction. So I start by assuming it's not irrational, right?
Yeah.
and then I show you what would happen. And you're like, whoa, that's like two trains heading right for each other.
Yeah.
And that's the symbol we tend to use in mathematics, the contradiction. Two things were going and they hit each other head on, and it can't happen. So
Okay.
therefore, it has to be irrational. Mhm.
Okay. So you use the definition of,
This is one way. I said there's a couple ways. This is one way. The other way goes back to the definition of a rational number in decimal form. So a rational number in decimal form is what? Terminating or
and repeating or repeating.
repeating. Okay. And irrational?
It's non-terminating and non-repeating.
Non this and non that.
And if you add them,
Add those together,
it's gonna just
it's
keep
going to be
going.
non-terminating, non-repeating. There's
Yeah.
no way I could do that and get a repeating value. There's no way it would terminate. So we know that's out right away.
Yeah.
And so the only thing that's left is repeating, and putting a repeating number with non-terminating, non-repeating means it's going to be non-repeating. So there's a couple ways, like I said.
Okay. Okay. That makes sense to me. My next question was, I kind of need like a refresh of like the union, the and, the or, the
Question
sign.
10.
Yes, question 10. I'm like looking for it. Where is it on my paper? Okay, yeah.
That's all right. Like I said, I did all the homework, so I know. I'm pretty sure if you're saying that, I'm pretty sure which question you're referring to,
Yeah.
but I'll check just to make sure. All right, so let's see here. So, what do you remember? Because this is back in chapter 2, and we should still know these. But let's see here.
Yeah. Okay, so well, I know if it's and, they both need to be true. And then I know, well, but also by definition, isn't it them? Is it intersecting? The intersection of the two sets.
Mm-hmm. Yep.
And then if it's union or,
Yep.
one has to be true or both.
Mm-hmm.
And that's like the two sets combined, right?
Kind of.
The union.
Mm-hmm.
Okay. But what does that dash mean? All in set
Oh,
S, but not in Q?
like a this, that's the
Yeah.
set difference.
Set difference. Okay.
Mm-hmm. That was in chapter 2, maybe 2.2, maybe something like that.
Okay.
So
So
set difference.
but what does that mean? Like,
So if I had A is a 1, a 2, and a 5, and set B is a 3, 4, 5, 6, then A set difference B is the set of all things in A
not.
that are not in B.
Okay. So it would be 1 and 2.
Mm-hmm.
Okay.
You can also think of this as
A
intersect
intersect not B.
B complement or not B. Yeah. And if you say
Okay.
it that way, it's A and not B. Yeah.
Okay. So really it would just be everything in A, not in at all B or their intersection.
Mm-hmm.
Okay. Okay. So like with knowing this,
Mm-hmm.
would everything in S that's not in Q,
Yep.
S being irrational and then Q being rational,
Mm-hmm.
would it be S? Because it wouldn't be R.
No, because R is rational, and what would R be?
R is rational and irrational. So it'd be Q
Mm,
and S.
we can't say and there. I know you want to say and, but and means both have to be true, and there are no numbers that are in both. So it's actually an or,
Q
it's a
or.
union. You can be a rational number or you can be an irrational number. It doesn't matter to me. But if you're either one of those, if you are at least one of those, you're in the real numbers.
So it is R.
So Q union S is R. Yes, that is Q union S. You have this statement.
So
So
S
take all of the irrational numbers.
Uh-huh.
And then from that set, I want you to take out, what are you taking out?
All the rational?
How many are in there?
A lot.
Are there? There are a lot of rational numbers in the set of irrational numbers.
Wait, there's none.
Hmm.
So it is S. Okay. So, but if it said R not in Q, it would be S.
What if I said this? That is a good, yes, that's a good what if. What if I have all the reals and I take out the rationals? Then it's this. What if I have this?
Then it'd be Q.
Mm-hmm.
Okay. Okay, that's good. I feel like I just made a bunch of like guesses on all of these.
Don't want to be doing that.
Yeah. I want to know why. Okay.
Good.
So so Q, which is rational.
Yep.
Q and integers. Wouldn't that be, would it be I? Because Q and integers.
Because you
Wait.
have to pick numbers that are in both.
Okay, Q is rational. Yeah, it'd be I because there's no Q in I.
There's no 2/3 in there. There is Q in I. It just happens to be the I part.
Yeah. Okay, Q. I don't know why the Q isn't sticking with me to be rational. The letters are just like,
Well, like I said, whenever I see it, because I'm in the same boat, I want to think of like an R statement because it's rational.
yeah,
So just think of this as quotients.
yeah,
Like think of that fraction as a division problem because it really is. And
quotient.
you're like,
Yeah.
oh, it's just quotients. That's all.
Okay.
Maybe
Okay,
maybe that'll help. Who knows? Maybe it will. Maybe it won't.
so it would be I because if you have Q,
Mhm.
which is rational numbers,
Yep.
and you have I, what's in them both?
Mhm.
The intersection is I.
Has to be in both.
Okay. Okay.
You can definitely tell that I is in I because
Yeah.
that's the definition. Is everything in I in Q? And you'd say yes.
Yes.
Then the question becomes, is there anything else in Q that would be in I that I haven't already included? And you'd be like,
No.
sorry.
Yeah. Okay.
But if you draw that picture, I drew it today with kind of the lines like it did in the book because someone said, I don't see where the book piece comes in. So I showed the book one, but I
Yeah.
still think it's better to think of like your natural numbers being kind of that building block. And then
Yeah.
we grew that to be whole numbers. And we grew that more to be integers. And we grew it even more to get your rational numbers. And then we have this huge box, which we call the real numbers.
Mm-hmm.
And your irrational numbers are simply the ones that are out here.
Okay. So the universal set would be R.
In this situation, yes. If you get higher in math, we would make it broader. In higher in math, you'd have the real numbers and you'd have the imaginary numbers,
Okay.
and those combine to make the complex numbers. But we're not, that's,
Yeah.
again, that's high school-ish stuff. We're not going to do that. We're just going to say for us, the universe that we are really thinking about for our students would be the real numbers.
Real numbers. Okay. And I thought that's one of the questions. And it asked if the universal set is R, how would you describe not an S?
Yeah.
I put imaginary. Not
Really?
an S. Wait, not in, what is S? Irrational.
You sure about that?
Would it be Q?
I'm asking you. What is S?
S is irrational.
And I'd
So
like something that's not that.
it would be Q.
Hmm.
Well, it could be N, W, I, or Q. No?
Could not be.
Why?
And here's why. If you say S complement is I, right?
Uh-huh.
Then you are saying either I'm in this region out here or I'm in this region in the middle. And this band does not exist. So you cannot go to a subset of the set you're looking for. You have to say the exact complement. What does it mean to not be irrational. Does that mean, Jenna, that I have to be an integer?
No, because you
Oh,
could be,
I
yeah,
could be
you
two
could be
thirds.
rational.
That's fine, right? I could be
Yeah.
0.25. That's fine. Or 0.25 repeating. That's fine. Yeah.
Okay.
So that's why
Okay.
you, even what you're saying is, but the integers are not irrational. And I would say that is true. They are not irrational, but they are not the same as the complement of the irrational numbers.
Okay. Because if I were to say it were I, it'd be excluding
Correct?
Q.
Yeah.
Okay. Okay. That
Yep.
makes sense. Okay. I just needed that like
Hmm.
refresh. Um, what's question? My next question 16. Oh, it's the geometric sequence.
Love that one. That's such a cool
Mm,
problem. You're not as big of a fan. Okay. Well, what's the issue with it? You know what a geometric sequence is, right?
well, yeah, it's like multiplication or division, right?
Okay. Well, because
Ratio.
division we know is now multiplying by the reciprocal. So
Yeah,
just think of it
but
as multiplication.
I feel like I don't have enough information.
Really? For which one?
All of them.
Really? Let's try this then. Now we're talking. Now we're talking. All right, let's try it. Which one you want to start with?
We'll start with C because it looks the hardest.
C looks the hardest. I think it's the easiest because you have two terms that are right next to each other,
Yeah.
right? So you're telling me that in a geometric sequence in general, if I had some term and then a blank term and then another term, whatever I put here, how do I get from this term to the next term?
Multiplying
By what?
a common ratio.
So don't you know what that looks like then?
So it would be that times the ratio.
And if I wanted to do it again, now what would it look like in this final case?
It'd be um that and then ratio again. Times 2
Times 2,
or squared.
because I multiply by the ratio. Well, ratio times ratio would be ratio squared. So if you're looking in part C and you have some blank spaces here, so I'm going to ignore those temporarily, because right now you should be able to tell me what that ratio is. Oops, wrong.
Would it be 1 over? So to get back, so say I'm going the other way, it would be
Oh, I'm not trying to get, I'm just, how would I get this way?
you'd be multiplying by square root.
Don't fight it. Just write it.
You're multiplying by R.
Start with 2,
Okay.
multiply by R. I end here. That
2
seems weird,
divide by 2.
but this is the concept over here, right?
Uh,
Now all I want to do is apply the concept here. I've got my starting one, I've got my ending one. Here's R. So now get me R by itself.
you have to divide by 2.
Okay, so what would I say?
R square root 2 over 2.
Okay. So now you know what you're multiplying. So if you want to go the
Oh,
other direction,
okay.
what would you multiply by to go the other direction?
The inverse.
The multiplicative inverse, which would be what?
2 over square root 2.
Okay. So now if we write this whole thing backwards and we start with the square root of 2, because that's, again, I'm trying to go this direction.
Yeah.
And now you multiply by 2 over the square root of 2. What do you end up with?
You end 2 because they simplify. The square roots of 2 cancel out.
Common factors. Guess what? FLOF works even with the other numbers, so kind of cool. So you end up with 2.
Okay.
Now start with 2 and multiply by.
So it'd be 4 over the square root of 2.
Okay.
That can't simplify though. Like we just leave it there.
It can. Do you want to get into that, or are you good with 4 over square root of 2?
On the test, can I leave it like that? 4 over square root of 2. That's
Yeah.
what I'm, yeah. Okay, but what if it was like, this isn't part of the question, but I know that it's kind of on the homework. If it was like 2 times the square root of 2, would it just be like 2 square root 2?
Mhm.
Okay, because in between them, there's like an invisible multiplication.
Yeah,
symbol.
just like if I write XY, that
Okay.
means X times
Okay.
Y. Mhm.
Okay, that makes sense.
So we got 4 over root 2. Do you want to finish it or you feel good now?
I feel good with that one.
Okay. No, I'm gonna make you do it. Show me that you're good with it.
Okay,
You
so
got it
then
down. I'm not gonna write it. You write it. What are
okay,
you gonna
so
come up with?
then I'm gonna multiply this one 4 over square root 2.
Uh-huh.
I'm multiplying that again by
Mhm.
2 over square root 2.
Uh-huh.
That's gonna be 8 over square root. I I don't know why this is, but it doesn't equal 2. Square root of the same thing equal what's in the square root.
Well, that beautiful property of exponents in this section says if you have square roots multiplied together, because exponents distribute across multiplication and division.
Oh, so it'd be square root of 4, which is 2.
What's your final answer then?
So it's gonna be 4. Okay.
That didn't seem so bad.
No. Okay, so that was the easiest one.
Yep.
Okay. So how would I do it if
Pick one of the others. Just pick one. I
um
want you to try to talk your way through it a little bit if you're okay with that.
yeah,
Okay, pick one.
I'll just do A.
Okay, do A. Okay. You talk, I'll write a little bit.
Uh what was can I do what you did the last time before the last test where you subtract the 2, or is that to find how many? That's you can find the common ratio doing that, like 8 minus 4. Yeah.
Okay,
So okay, 8
let's
minus
try it.
okay. 8 minus 4, that's gonna equal 4. And then I'm dividing by how many jumps?
Hmm.
Divide that by 3.
Okay.
Okay, so that's gonna be 1 and 1/3.
Okay.
I think that might be for arithmetic. Let me
Shall
try.
we check it?
Yeah.
Go ahead.
So I would try so I do 4 times 1 point. Can I just do 3, 3, 3?
I wouldn't.
Okay.
Go back to your fractions. They're your friends.
Okay. So 4 times 4 divided by 3. 5.333. Okay.
So 5 1/3.
Yep. And then I'm gonna times that by
But
4.
before you go on, can we just do the distributive property so you can see that it's not as bad as you were making it?
Yeah.
It's 4
Uh-huh.
plus 4/3, and you already said 4/3 is 1 1/3. So I get here with no decimals needed,
Okay.
right?
Yes.
Because that's it. Okay. Just making sure. I'm not telling you what to do. Just okay. Now what am I going to do next?
I'm gonna times 5 and 1/3 by 4 over 3. Okay.
Okay.
And 1/3 times that by 4 over 3. Distribute. It's gonna be
Yeah, this one I probably wouldn't distribute because this is going to get ugly with distributing.
okay. So I have, what did I do before to even get that in my calculator? Okay. 16 divided by 3 times that by 4 divided by 3. I get 7.111. So
Crazy kids. You kids with your crazy calculators. So you multiply straight across, you get 64/9. 9 goes in there 7 whole times and leaves you with 1/9. And you now know 1/9 is that,
okay.
right?
Yep.
Okay.
1 over 9, because that gets you the repeating
Yeah, got you repeating.
numerator.
Gotta love that.
Okay, and then I'm going to times that by 4 over 3 again.
Okay. So I'm going to go back to 64/9 though, right? Because I do not want to multiply 7.1 repeating by 4
Yeah.
thirds. Okay, good.
Well, it doesn't get me 8.
Are you sure?
Um,
64, was that 256? Over 27?
256 divided by. No, it gets me 9.481481. Doesn't give me 8. Okay. So is that only for arithmetic, that thing I just did?
And why is it for arithmetic?
Oh, the subtraction. Oh. Okay, so I can change that sign.
Could. You could. Or you
So
could go back to the concept that I had drawn on the screen a little while ago.
the concept.
The
Mm,
one that looked like this.
yeah.
And I ask you, how do I get from here to here?
You multiply
So
by
we
a
got
common
it.
ratio.
Okay, so what's your common ratio?
I don't know.
I
R?
love it. Let's call it R. So if you were to do that same thing, what would you get here?
I'd get 4 times R.
Or R. Are you smelling smoke? Can you hold for 1 second?
Yeah.
Just in case the building's on fire. I don't think it has fire alarms, so give me 1 quick second.
Okay.
You smell that too? Right, my nose is. Okay. All right. Get the walls, but they'll burn it down later. Okay. Sorry about that. Oh, I
It's
should have
not.
paused the video. That's great. That's gonna be there forever. All right. So we got 4R, right?
Okay, yeah.
Okay, keep going.
And then
What's
it'd be 4R squared.
Oh, okay. Well, that was easy. Okay.
So then work backwards.
And well, you're not there yet.
Okay.
You're not done yet, are you?
So then it'd be that 8 is going to be 4R cubed.
And that is how you do these problems.
So
I swear I'm still smelling something. Hold 1 second. Is it me? I don't. Okay, now it smells more like burning sawdust. So maybe it's something from the construction. Okay. All right. I'm gonna get back to my student. Okay. Sorry about that. My office mate and I are investigating. If you see flames behind me, just at least let me know. That will go from
I
there.
was trying not to laugh because I was like, I don't want it to all burn down, but
No, it's hilarious. My wife does this to me all the time. Like I come in the house, I'm like, oh my God, I smell gas. She's like, oh yeah, look at that. I didn't turn that off all the way. I'm like, okay, you're doing that to me on purpose. So, all right, let's see here. So you were right though. You said 8 is 4R cubed. Right?
okay, and now I solve.
Yeah. Now you
So
solve.
I would divide by 4, I get 2, and then R cubed. So I would do like the cubed root of 2. Okay.
There you go. There's your ratio.
How do I like plug that into a calculator? Or can I just put
What calculator you got? Hold it up. Yeah, you got it in there. You got 2 options. There is a 4th root on the TI. It's an nth root. And I think it's under the math. Oops. I screwed that up. I can't do that. Give me a second. Let me look on where it's at in the calculator.
I do think you're right. It is under math.
I think it's math, and there's like an nth root. Do you see it?
Yep.
But if you don't want to do that, because I mean, I use that calculator for a long time, so I know it really well. I would do 2 raised to the 1/3 power because it was quicker than trying to find where the submenus were.
I forgot that that's what it was.
But
Okay.
why do you want that?
Why do I want it?
Yeah. Why do you want the decimal form of that?
Because I'm gonna multiply it.
I mean, what if you didn't write the decimal form of it? What would it look like?
It would just look like, I don't know, 2 and 1/3, 4 times, and that's fine.
There's nothing wrong with it. You write a decimal number down for an irrational, you're never going to get it right.
Okay.
You'll have a decimal approximation, but if you use that decimal approximation going forward, you won't get to 8.
Okay.
So what if you just left it like this? What would your next one look like then if
So
we
then
did
it
this?
would be, my next one would be 4
Mhm.
to the cubed root of 2 squared.
Yep. Yeah, that's it.
Okay.
Okay. And what's your next one going to look like?
It would be 8.
Come on. No cheating.
Okay, so it would be 4 to the cubed root of 2. Oh, cubed, but the 3's cancel out. So then it would be 2, and then 4 times 2 is 8. Interesting.
Yep. Now,
Okay.
that is the idea.
Okay.
You don't have to have that shortcut approach.
Okay. Okay. And I'm just
But
gonna do,
would you like to see the shortcut approach?
yeah. But that is how I would solve
Yeah, that's
for
fine.
all the others.
You can do it for as many terms as you want because you think about the concept. The concept is I multiply to get from one term to the next.
Yeah.
So it doesn't stop me. So I don't care what this one is. I know I multiply by r to get here. Then I multiply by r to get here. Then I multiply by r to get to here.
Yeah.
So I could even start with 1 because I know I multiply by r. So I'll just call it r. Then I multiply by r again. So I get r squared, and r squared has to equal 2. And then I can solve that. Yeah.
Okay.
So I know you're the what if and the could I, what if I tried this kind of person. So what we did with arithmetic, if it was this, right?
Yeah.
I come in the wrong place, is we would do 8 minus 4 to find the total difference
Yeah.
and then divide by the number of hops, which was 3, right?
Yeah.
And that would be my common difference. Well, geometric is very similar. Look, you even have a map of it here. What did you do? Don't simplify this time. You had 4 blank blank. God, I mean my commas. 8, right?
Yeah.
And so you would say 8 divided by 4. And you divide it up here because you'd be multiplying by your pieces to get there. So here you have to undo multiplication by itself. So your number of steps is still there. It's just listed here.
Okay. As the x root or nth root.
Yeah. So if I gave you this exact same problem, like give me another term in the middle, you're like, fine.
4 hops. So 4.
Rocks. Just like if I would have come up here and given you another term in the middle, you'd be like, fine, whatever, dude.
Interesting. Okay. And then since that's my common ratio, I could just put,
You just multiply, 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 multiply. Yeah.
okay. Okay. Awesome. I'm gonna do the other ones by
Should.
by myself. And then if I have any questions, I'll ask
I've already
on.
cleared my screen, so I don't know what you're talking about.
Okay.
Did you have another one before we, or do you have a couple more?
Yeah. Okay, so 22. What was my question for 22? Oh, like kind of the rules for if I have an irrational number.
Yeah.
like in the is it not square root? I don't know. Yeah, the little root thing. What can't like do I just like subtract what's in the roots? Like on question for 22, question B.
Okay. So this is why I wish the book did a little bit better job of talking about the concept of addition and subtraction. They mentioned it when we got to fractions, that if I have 2/3 and I want to take away 5/7, that I cannot do that directly because I'm not adding like objects.
Yeah.
They mentioned that. I wish they would have done that again here. 2 square roots of 50 and 8 square roots of 5 are not the same thing.
They're not. Okay.
So I would have to try to simplify these to see if something does subtract. And in this
Okay.
situation, you could look at this and say 2 times the square root of 50. Well, 50 we already said is what, 25 times 2? 25.
Yeah. Wait, so
times
is 2 square root 2 of
Yeah,
2 square root 50? Is it
sure.
100 square root? Could I say that?
You tell me. Is the
Yes,
square root of 50 plus the square root of 50, is that the same as the square root of 50 plus 50?
I think so.
Okay. Well, why don't I pick a slightly different example? We'll see if you still feel that way. Because this is also what you want to do as a teacher, right? You want to see what people know, and then you want to lead them without telling them.
Yeah.
So here we go. Why don't I do something nice like this? Square root of 16 plus the square root of 9. Okay. If we do it your way, we get this, right?
Yeah.
Okay. Square root, what is 16 plus 9?
16 plus 9. That's going to be 20. What is that? That bad. I don't know. Okay, 16. 25.
And the
Which
next
is
time you
5.
do a 9, and the next time you do a 9, would you do this for me just to save your life and make things so much faster so you feel like a genius? Because when you do it, like when you think of 9, it's hard because it's one of those that trumps over, right? So don't think of it as 9. Think of it as 10 minus 1. And you can add 10 very quickly, and then you take 1 away, right?
Yeah. Okay.
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 All right.
Okay, so 25. So 6 square root of 6. So I know that the square root of 25 is 5.
Okay, good. I like that. How about over here on
Square
the left?
root of 16 is going to be 4.
Okay.
3, which is
Okay.
not 5.
Hold on. You told me it was, though. You said down over here, you said you can take these and add them together and it works just fine. Well, what do you
So
think now?
no, you cannot.
Okay.
Okay.
Square roots distribute across one
Roots.
level.
Okay.
Multiplication and division distribute across one level.
But square roots are exponents.
Square roots are exponents. Remember, the square root of 50 is an exponent 1/2.
Yeah.
So you treat them exactly like exponents, and they absolutely do. And there's some places that will actually put an R down here. Exponents and roots, they'll kind of group those together.
Okay.
But
so
once
I
you start
can't
messing
jump from E to A.
cannot
Got
any
it.
more than you can say 3 plus 5, if I want to square that, is the same as 3 squared plus 5 squared. And you do the math on that. This is 8 squared, and that is not the same as this. It's nowhere close.
Yeah.
So we got to be really careful when it comes to exponents. So that's, you get 1 step. Distributive property grants you 1 step, but it doesn't get you 2.
Okay. So what I did was I broke that question down into like I broke 2 root 50s into primes. I wrote the 50 into primes.
Okay.
Just to
What'd you get?
see 2 times 5 squared.
2 times 5 squared. Now I want to take the square root of that. So we'll use the little tip from class today. Or I'll just do the quick division. We know it's a base of 2. So 2 goes into 1 0 times, and it leaves me 1 remaining.
Yeah. 2 goes into 2 1 time. So that'd be 5. Yeah. And then, I didn't give you my simplified. I got 10 root 2.
Because then you brought the 2 in.
Yeah.
So 2 times the square root of 50 then would be the same as 10 times the square root of 2. Yep.
Yeah. And then minus 8 root 5.
Okay. Are those like objects?
No.
They're
What
not
makes them
objects.
like though?
Oh, what if I had this?
So the root makes them like.
If they match, then they're like objects.
So that would get me to root 2.
Yep.
Okay. And what makes them match is the root.
The root and the index both have to match, otherwise they're not the same type of object. Like if this was
Index.
a cube root of 2 and this is just a square root of 2, then they
Okay.
would not match anymore. They wouldn't be the same.
Okay.
So
And
yeah, you
so
look at these and you say, I'm sorry, I can't simplify this any further.
they're
And there's
irrational.
no way they're matching up. Yep.
They're irrational. Okay. All right. I think that was like my main question. I just didn't know what made them like, or
Yeah.
like, like common denominator.
Like this one, like this one in part A though, because roots distribute across division, you could rewrite that one.
I found all the primes, but when I looked
could.
it up, all they did was divide by 20. Like
Because roots distribute across multiplication and division.
So technically that's that.
So these are exactly the same. So if you see a square root on top and a square root on bottom, you can just be like, yeah, I'm just going to do this. And then this goes away.
Yeah.
And then 32 divided by 2 goes away because you can do that math. And now you're sitting here.
And that goes in perfectly. 4.
Making that determination is a little bit easier. Yeah.
Okay. Yeah, that would have saved me some time. Okay.
That's all right. And that's part of this class too. It's okay to, if you see doing things the long way gets you to a certain place, you constantly look for ways to do it more efficiently. You're like, how could I get there? I got the right answer, but could I do it in a better way?
Yeah. Okay, that makes a lot of sense. I have another question on the another true or false, 23.
Really? Number 23. I am shocked. I had no idea that was coming. I did scroll down exactly to 23 because I thought for sure she's going to ask about 23. All right.
Yeah.
What do you got?
Okay. I made my like predictions, but I didn't prove them. For A, the set of real numbers is closed under subtraction. I said true because, like, thinking of the picture, real numbers include irrational and rational, and rational includes everything else we've talked about.
Yep.
So
remember, real numbers as a quick definition is a number that can be represented by a decimal.
So yes, I think.
Is that always then?
Always, yes.
Okay.
But so this is on the test. I pick always. What am I saying to explain it?
I take some decimal number, I subtract the decimal number, I'm going to get a decimal number.
The decimal number. Yeah.
That's it.
And it could be an irrational decimal number, but that's still a real number.
Doesn't matter.
Okay.
I can represent it with a decimal.
Okay. So
now notice every one of these where it says real numbers, right? I mean, because we're getting near the end of the class now. If this was back on test 1, then I would have said whole numbers, right?
Yeah.
Or even natural numbers. For test 2, it would have been whole numbers. For test 3, it's going to be integers or rational numbers. I mean, so just think, I mean, even though it says real numbers, your thought process should be, okay, hold on. What would happen if he gave me, because the what if question is the right one to play in any class you take. But yeah. So yeah, here, the whole reason we got up there was the whole numbers were not closed under subtraction.
Yeah.
We remember that. 3 minus 5.
Yeah.
That's not a whole number. So that's why we created the integers, is now we have closure under subtraction. So the integers are closed under subtraction, the rationals are closed under subtraction, and the reals are closed under subtraction.
Okay.
You've already seen irrationals are not closed under subtraction because an irrational minus an irrational could become a rational number.
But irrational is a real number.
It is. That's correct. So what I'm saying, I was taking each individual set separately.
Individual sets. Okay. Yeah. Okay. Yeah. So then the set of real numbers is closed under multiplication. Yes.
So always or sometimes?
Well,
And this is kind of a silly one because you'll never have a
I think
sometimes.
always.
You'll never have a sometimes. Because when it says it's closed, it means it has to be true for all numbers. So this
All of
one's
them.
like it's got to be in all numbers. So I probably wouldn't word it that way. And I mentioned this in one of the videos. I said I probably wouldn't word it that way. I would say if X and Y are elements of the real numbers,
Oh.
then X minus Y is an element of the real numbers. So this is just if I subtract these two numbers, do I get another real number? And you would say
Yes.
that's true all the time. It's true sometimes. It's true never.
Which is
That's how
all.
I would phrase it. I
Okay.
probably would. I'd say um, X minus Y is a real number. I might not even use the symbols here, but is a real number.
Okay.
Or X times Y is a real number. You know, that's what I would probably say instead. When they say it's closed, then it can only be that it is absolutely closed, or you would have to say it is not
Yeah.
closed. So if it fails once, then it fails. And that's
Yeah.
what's different with this one. So just be
Okay.
aware of that little bit of a tweak. I probably wouldn't, and I mentioned that in one of the videos. I'm like, I'm not going to word it that way. I
Yeah.
don't like the way that's worded.
Okay.
And I
So
did say there's a typo in C. So
that was my next question.
mhm.
Okay. So multiplication, yes, I think it is always closed.
Yes,
And because when you multiply,
just say it's closed. Don't have to say it's always closed. This would just be, is it closed? And you would say, yes, it's closed. Because if it's closed, it means it's true for all real numbers.
okay. And then what's the typo in C? If A times B, then if A times B equals 0, then A equals 0 or B equals 0 or both equals 0.
Hmm.
True. Right? Because A or B or both. Yeah. Okay.
Correct. But without this part saying equals 0, I have no idea what the hell they're talking about. I'm like,
Yeah.
if A times B, if A times B, that's a multiplication. That's like saying if 7. What does that
Yeah.
mean? What do you mean by that? So I think they need me back editing their books because I have a whole list of all the typos and everything. But anyway,
You should
that's
just
okay.
write your own book at this point.
I have already, just not for this class.
Oh, but a math book?
No, I got
Oh,
2 of them. They're out there
wow.
free for everybody.
Wow.
I know you
Wh-
might look through it and be like, "Oh, this would be so good for this class." Maybe.
Why can't, could you,
It was for a math fundamentals class. So it was one of the books was math fundamentals. So it really was kindergarten through 8th grade math, but not for teachers. It was for students. So it approached it in a very different way. Um, Most of the time students, if they're struggling with math and they get to college level, we just keep showing them the same way over and over again. And so I
yeah.
wrote a book that said, why don't we stop doing that? And
Wow.
then I decided like an idiot to just give it away because that's what some of us do.
You should link them on the canvas so
Oh,
we can.
so you can all see it. It's out there. It's on the MiraCosta website.
Oh, really? Well, I didn't look it. When I saw you were my instructor, I didn't look you up on Google.
Oh, well, thank you for that, I suppose. There's a limit to to the stalking of the students and how far they go. Yeah, it's just in the STEM Learning Center. There's student resources, and one of the resources is math. And under math, there's a Math 28 and a Math 102, and all the textbooks and materials there are mine.
Oh, so people use your textbooks at Miracosta.
They could. They were provided free as PDFs. So
Wow. How
yeah, but
cool.
what are we doing here? What are we doing here? We're doing yeah, so I actually grouped it. So we have ratios, division, multiplication, addition, subtraction. So all of the pieces, like I didn't group it as whole numbers and then integers and all that. I did them all in one because addition, the concept of addition stays the same throughout.
Yeah,
And so that's that was that
that's
was the
so cool.
approach. Yeah. Anyway, so there you go. Let's get back to where you were
Okay.
at. So those are out there. If anyone wants to, you can go out and look. There's a lot of things that are very connected to what we're doing in this class. Um, yeah, like there's a
You
whole
wrote them in 2017?
Looks like that's the last date this one was modified. They actually stopped teaching the class. So I did 4 editions and the last one was summer 2018. Yeah. Prep
Cool.
percents, solving percent problems, proportions, ratios, slope, and yeah, look at that. His perfect crepe. 8 ounces of eggs, 8 ounces of milk, 4 ounces of flour. Fantastic. So we make ratios and find the ratios in these situations. It was a kind of an explore, the workbook. So their textbook actually had this stuff where they would explore in class together and like be integrating, like what we do as activities. They like integrated that. And
Yeah.
then we would do some together, which is an interactive example, and then they would go do some on their own with each other. That was kind of the idea. So
Interesting.
there's
And
proportion.
that was like math 28. That's like
Yep.
support
Beginning.
math.
Very, very kind of
Intro.
beginning. If you were struggling, you tried to take high school math, didn't work for you, or you dropped out of college, dropped out of high school, dropped out of college, then yeah.
Yeah.
But and try to make it realistic. We did proportions with putting in milk and flour to make kind of a crepe recipe, and how can I change the ratio?
Yeah.
What if I doubled each amount? Does that make it good, lumpy, or runny? Kind of so you're thinking about it as you go.
Yeah. Why don't you use this as the activity manual for us?
I was told this is the one that I gave you is the one that was required. So
Oh, well, for
yeah,
future. I don't
I
know.
know. And I already told him, I said, I think we need to not charge people for that book because
Yeah.
I'm obviously not a fan of it. But yeah, and we did ratios and proportions and we did medicine with what happens with kids. They base the medication on the weight of the child. And so
Yeah.
we did something like that.
It's pretty cool.
Chainsaws, cookies, baking, construction, nursing, working with gold. I don't know. Yeah, we tried. Yeah, I went years of my life on that. And then they decided to cut the class, so it's gone now. But the book
Well, maybe
remains.
they'll bring it back though. You never know.
Yeah. All right, let's get back to your question. So maybe you got
Okay.
a few more here.
Um, 23. Okay, so true, true.
Hmm.
Which one did we do? True for C.
Hmm.
And then D, there is no least whole number. There is a smallest whole number, 0.
Hmm.
Is that what it's asking?
It says there is no least whole number. And you would say,
False.
because
0.
there is a least whole number. Correct.
Okay.
But
And
remember, if I change that from whole number to integer,
well, there's false because it goes on forever. It's like infinite.
there you go.
Okay. But
There
whole
you go.
number, we know it's 0.
Whole number, there is a smallest one. There is a
Or
smallest
natural
natural
number.
number. Hmm.
Yeah, 1.
Yeah.
Okay. Okay. And then the set of integers is contained in the set of natural numbers, which is false. The set of natural numbers is contained in integers. Okay.
Yeah.
Okay. Um, that is good. And then what was my other question? Oh, last question. 24A. I got 3.
Oop, 24A. Okay,
I did cross multiplication and I know.
that's fine.
Okay.
You can use it. You
Yeah.
just got to know when you can use it. Like it should, so yeah, there's nothing wrong with that.
The
You,
equal sign, right?
it's not
Like
just an equal sign. Mm-mm.
what else?
It has to be
Inequality?
a ratio. A
Okay.
ratio equal to a ratio allows you to do this. So what some students will do is they'll see this and they will do this.
And not include the X.
And they just ignore the X because they have seen things that look like this and they know what to do. Their teacher said, if you see things that look like this, do this. And
Yeah.
instead it's like, no, that's not exactly what we have. So yeah, so
Okay.
here you could, but again, you have other options. You could flip them both over
Flip. Oh.
because it's ratios. So just flip them over. And then you want to get X by itself. So you just have to multiply by root 3.
Wouldn't the two roots cancel each other out into 1?
Interesting thought. So square root of 3 times square root of 3 becomes what? Oh, you mean
Square.
on the right-hand side?
No, like cross, like a cross.
I'm just saying there's another way you could do it. The way that you did it, square root of 3 times square root of 3 becomes 3. And the reason why what you did this time is probably the most efficient is because X times 1 is just
Okay.
X.
Oh, and X, square root times the square root and they're the same equals what's inside, because if we put
Oh,
them
it's just
together.
roots, no matter if they're the same or not. If as long as it's the same index, when you multiply them, roots
21,
distribute across multiplication.
which is 21.
So yeah,
Okay. But in our case, it works out good because.
it just worked out because you had 1 times
Fine.
x and it just
Okay. Okay.
kind of fluke. But yeah, if you reversed it, you'd get the same thing. Square root of 3 times square root of 3 is 3 equals x. You know, if you flipped it over and then solved, yeah.
Okay. All right. I'm good then. I think I was just thinking of every what if and then psyching myself out.
All right. Was
But
that was it? And no MCs?
no, I haven't looked at the MCs yet. I just
You
wanted to
felt like
get
you want to get
these.
those done before you move. Okay.
Yeah.
All right.
Thank you. Thank you.
All righty. Take a breath. We'll see you later.
Bye.
Bye. Oh, wait. Off you go.